terus Merdeka Belajar dan Kampus Merdeka itu untuk S1 S1 yang untuk kesehatan masyarakat dan bagus mungkin teman-teman yang mungkin punya kompetensi yang bisa kemudian mendalami yang terkait dengan kita bahannya, terutama yang terkait dengan ilmu. Karena kan saya tidak ahli.
Belum mulai ya? Telkomsel lagi 2G. Apa?
Pesatnya kemajuan dan perkembangan ilmu gizi sejalan dengan pengembangan ilmu kedokteran dan kesehatan. Tuntutan akan perkembangan ilmu gizi tidak hanya terbatas pada taraf akademis saja, melainkan juga pada taraf profesi. Salah satu kendala yang dihadapi adalah terbatasnya jumlah tenaga gizi yang ada dalam unit pelayanan gizi dan kurang sesuainya kompetensi tenaga gizi yang ada dengan lingkup permasalahan ataupun program yang berkembang. Fakultas Kesehatan Masyarakat Universitas Airlangga siap turut andil dalam memenuhi kebutuhan tenaga ahli gizi berkualitas.
Fakultas Kesehatan Masyarakat Universitas Airlangga merupakan fakultas yang pengembangan ilmunya multidisipliner. Terdapat program studi S1, S2, dan S3. Untuk yang S1 ada 2 program studi, yaitu Ilmu Kesehatan Masyarakat dan Ilmu Gizi.
Untuk mempersiapkan dan mempercepat pemenuhan kebutuhan tenaga ahli gizi, maka diselenggarakan pendidikan akademi strata 1 S1 Sarjana Ilmu Gizi.
Program studi Ilmu Gizi merupakan salah satu program studi yang terdapat di Fakultas Kesehatan Masyarakat Universitas Airlangga. Area kompetensinya meliputi 3 bidang, yaitu Clinical Nutrition, Community Nutrition, dan Food Service Management. Didukung oleh tenaga pengajar dosen lulusan perguruan tinggi ternama, baik di dalam negeri maupun di luar negeri, serta fasilitas lab riset yang baik untuk mencetak ahli gizi yang kompeten. Lulusan kami dapat bekerja di berbagai bidang, di antaranya di rumah sakit, dinas kesehatan, puskesmas, industri pangan, maupun industri pelayanan makanan, dan NGO.
Visi program studi S1 Ilmu Gizi menjadi prodi S1 Ilmu Gizi yang unggul di Indonesia dalam menghasilkan sumber daya manusia di bidang gizi yang memiliki daya saing yang tinggi di tingkat nasional maupun internasional dengan excellence with morality.
Sebagai angkatan pertama, saya sudah 3 tahun menjalani pendidikan di Prodi S1 Ilmu Gizi FKM UNER. Prodi mendukung penuh baik secara moral maupun material, sehingga menurut saya Prodi pantas untuk diberikan acungan tangan terhadap dukungan ini. Oleh sebab itu, apalagi yang kalian tunggu, mari bergabung bersama kami.
Sejak awal berdirinya Prodi S1 Ilmu Gizi FKM UNER, Himpunan Mahasiswa Asosiasi Mahasiswa Gizi menjadi bagian yang memiliki andil dalam mengembangkan soft skill mahasiswa S1 Ilmu Gizi. Selama 3 tahun saya di Amazi, saya didukung penuh oleh Prodi S1 Ilmu Gizi dalam mengembangkan soft skill yang saya miliki.
Di dalam dunia perkuliahan, kita tidak hanya mengikuti kegiatan belajar mengajar, bukan, tapi kita juga harus aktif dalam mengembangkan potensi diri dan soft skill kita. Salah satunya adalah dengan mengikuti organisasi. Jangan takut untuk mengembangkan diri kalian di luar zona nyaman kalian. Hidup mahasiswa!
Prodi S1 Ilmu Gizi memiliki fasilitas penunjang sebagai berikut. Laboratorium pengolahan makanan digunakan untuk mengolah bahan baku menjadi produk makanan jadi. Laboratorium penyajian digunakan untuk menyajikan makanan yang sudah diolah untuk kemudian dinilai dan dicicipi. Laboratorium biokimia digunakan untuk menganalisis sifat kimia dari bahan makanan. Laboratorium penelitian organoleptik adalah suatu laboratorium penelitian mutu organoleptik dari produk makanan. Laboratorium komputer digunakan untuk melatih mahasiswa dalam menggunakan aplikasi-aplikasi kesehatan pada komputer.
Para dosen sebagai pengajar dan pembimbing telah membantu saya untuk memahami permasalahan gizi dan kesehatan, sehingga saya dapat mencetuskan berbagai gagasan solutif untuk Indonesia yang lebih baik. Dan akhirnya hal itu pula yang mengantarkan saya pada berbagai kompetisi ilmiah di tingkat nasional maupun internasional.
Berprestasi menjadi kesempatan bagi saya untuk berkontribusi lebih dan juga bermanfaat bagi masyarakat. Selain itu, berprestasi juga dapat menjadi keteladanan bagi semua orang untuk bergerak. Prodi S1 Ilmu Gizi mendidik saya untuk menjadi pribadi yang solutif sehingga dapat memecahkan permasalahan-permasalahan yang ada di masyarakat. Dan saya bersyukur menjadi bagian dari Prodi S1 Ilmu Gizi.
Wawasan saya jadi terbuka luas bahwa sebenarnya makanan adalah hal yang paling mendasar bagi seseorang, bahkan bagi negara, untuk mencapai kesehatan yang optimal. Prospek yang cukup luas adalah alasan saya mengapa saya memilih program studi ini. Kedepannya, saya ingin menjadi ahli gizi di perusahaan.
Dengan kuliah di Prodi Gizi, tidak hanya membantu saya untuk bisa mencapai prestasi di bidang akademik, tetapi juga di bidang non-akademik. Dengan begitu, memberikan saya peluang yang lebih besar untuk bisa mewujudkan pengabdian masyarakat sebagai bentuk implementasi dari Tridharma perguruan tinggi di bidang ilmu gizi. Nadon Rimo, Gizi Airlangga,
Act for Better, Go Nutrition.
Airlangga University is one of the best colleges in Eastern Indonesia. It is located in the Surabaya city. One of the best faculty it has is the Faculty of Public Health. The Faculty of Public Health of Airlangga University has 7 departments and 9 study programs at bachelor, master, and doctoral level. The Faculty of Public Health also has a Bachelor of Public Health study program at the UNER Banyuwangi campus. The Faculty of Public Health continues to show remarkable achievements as evidenced by its study programs that have been accredited A by the Dept and an undergraduate curriculum in public health that has been internationally validated by APEA, the Agency for Public Health Education Accreditation. As one of the pioneers of public health education in Indonesia, the Faculty of Public Health Airlangga University also encourages its students to be proactive and professional with entrepreneurial skill to solve public health problems at the local, national, and international level based on technological development and based on religious moral. There are 7 departments at Airlangga University's Faculty of Public Health, including Department of Health Policy and Administration, Department of Biostatistics and Demography, Department of Epidemiology, Department of Nutrition, Department of Environmental Health, Department of Occupational Health and Safety, Department of Health Promotion and Behavioral Science. From 7 departments, the Faculty of Public Health has 9 study programs, including Bachelor's Degree Program on Public Health, Bachelor's Degree Program on Nutrition, Bachelor's Degree Program of Public Health at Satellite Campus in Banyuwangi, Master's Degree Program on Public Health, Master's Degree Program on Health Policy and Administration, Master's Degree Program on Occupational Health and Safety, Master's Degree Program on Environmental Health, Master's Degree Programs on Epidemiology, doctoral program on public health. In addition to academic activities, students of public health faculty are also active in the non-academic activities such as choir, basketball club, dance club, traditional dance club, music club, community service, and other students' activities. Faculty of Public Health Airlangga University has various facilities to support the students' academic activities, such as computer lab, epidemiology lab, health nutrition lab, audio-visual aid lab, environmental lab, as well as occupational health and safety lab.
Wujudkan prestasi dan cita-citamu bersama Fakultas Kesehatan Masyarakat Universitas Airlangga. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi teman-teman. Perkenalkan, nama saya Alivia Hera, mahasiswi S1 Kesehatan Masyarakat Universitas Airlangga. Selamat datang di Kampus Unggul Fakultas Kesehatan Masyarakat Universitas Airlangga. Dalam kesempatan kali ini, saya ingin mengajak teman-teman sekalian
eksekutif mahasiswa serta area parkir motor. Sedangkan di area depan terdapat taman asri dengan mini amphitheater yang bisa difungsikan sebagai spot foto yang menarik.
Nah teman-teman, di lantai 1 terdapat 4 sayap yang mengelilingi taman yang indah dan asri. Teman-teman bisa lihat di belakang saya, keren kan? Nah di taman ini juga terdapat 2 gazebo, ada gazebo utama dan 2 gazebo mini. Biasanya area ini digunakan oleh mahasiswa untuk kegiatan akademik dan non-akademik. Dosen juga sering menggunakan area ini loh untuk kegiatan FKM. Teman-teman tahu nggak, di FKM UNER ada ikon public health yang menjadi spot wajib ketika berkunjung di FKM UNER.
Di lantai 1 gedung ini terdapat ruang dekanat, ruang administrasi, laboratorium komputer, laboratorium gizi, ruang alumni, ruang diskusi, dan ruang aula. Laboratorium komputer digunakan oleh mahasiswa untuk menunjang berbagai macam mata kuliah, antara lain statistika, komputasi gizi, dan sistem informasi.
Teman-teman, kali ini saya sudah berada di laboratorium gizi. Berbeda dengan laboratorium lainnya, laboratorium gizi memiliki beberapa unit lain di bawahnya.
Laboratorium gizi terdiri dari laboratorium pengolahan makanan dan dietetik. Digunakan mahasiswa maupun peneliti untuk merancang dan membuat produk-produk makanan maupun menu diet untuk intervensi gizi. Laboratorium organoleptik digunakan untuk menentukan mutu makanan. Laboratorium antropometri di mana banyak sekali alat-alat pengukuran dari yang konvensional hingga yang paling modern yang bisa digunakan untuk menentukan status gizi. Laboratorium gizi juga memiliki unit laboratorium analisis zat gizi dan biokimia yang terletak di lantai 3. Di laboratorium analisis zat gizi, mahasiswa diajarkan untuk menentukan kandungan berbagai jenis zat gizi dalam makanan. Sedangkan di laboratorium biokimia, mahasiswa dapat belajar untuk menganalisis spesimen manusia seperti darah atau urin untuk kepentingan pemeriksaan status gizi.
Sudah puas tur di lantai 1? Yuk, sekarang kita tur di lantai 2. Di lantai 2 terdapat ruang kuliah atau ruang belajar, ruang dosen, dan laboratorium audiovisual aid atau yang biasa kita sebut lab AVA. Terdapat kurang lebih 20 ruang kuliah yang siap digunakan yang terdiri dari berbagai kapasitas. Yuk kita intip salah satunya.
Ruang kuliah ini dilengkapi dengan berbagai macam fasilitas seperti LCD proyektor, AC, mikrofon, dan kursi untuk mahasiswa. Di lantai 2, terdapat laboratorium audio visual aid atau yang sering disebut dengan lab AVA. Di laboratorium ini, mahasiswa bisa mempraktekkan pengembangan berbagai macam jenis media yang dapat digunakan untuk edukasi kesehatan.
Sudah puas berkeliling di lantai 2, kini saatnya saya mengajak teman-teman untuk ke lantai 3. Nah teman-teman, sekarang kita sudah ada di lantai 3. Di lantai 3 terdapat ruang kuliah, ruang dosen, laboratorium epidemiologi, laboratorium kesehatan lingkungan, laboratorium kesehatan dan keselamatan kerja, serta ruang baca. Penasaran kan?
Laboratorium epidemiologi merupakan laboratorium yang menunjang perkuliahan di peminatan epidemiologi. Di sini mahasiswa belajar bagaimana cara melakukan screening kesehatan dengan berbagai alat antara lain blood analyzer, mikroskop, dan tensimeter. Di samping laboratorium epidemiologi, terdapat laboratorium kesehatan lingkungan. Di sini mahasiswa belajar untuk menganalisis berbagai macam parameter kesehatan lingkungan antara lain mikrobiologi dan kimia. Di lantai 3 gedung FKM UNER juga terdapat laboratorium kesehatan dan keselamatan kerja. Di laboratorium ini, mahasiswa mempelajari berbagai macam kondisi yang dapat mempengaruhi performa kerja antara lain pencahayaan, suara, suhu, dan kelembapan.
Nah teman-teman, saat ini saya berada di dalam ruang baca. Gimana? Keren kan? Keren dong. Di sini teman-teman dapat menemukan berbagai macam literatur yang dapat membantu tugas perkuliahan.
Selain fasilitas yang ada di fakultas, mahasiswa juga bisa memanfaatkan fasilitas lain yang ada di universitas, seperti masjid, asrama mahasiswa, gedung olahraga, perpustakaan, dan masih banyak lagi.
Sekian virtual kampus tour kali ini. Kami tunggu kedatangan dan kontribusi kalian di kampus ungu tercinta Fakultas Kesehatan Masyarakat Universitas Airlangga. Salam sehat, sampai jumpa. Assalamualaikum warahmatullahi wabarakatuh.
Oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Good morning, ladies and gentlemen. Welcome back to Public Health Airlangga University Summer School 2021, Understanding Human Body Composition and its Assessment Technique. Hello everyone, it's me again, Mulan. I'm a student from Department of Nutrition, Faculty of Public Health, Airlangga University, as your Master of Ceremony. It's great to see you again in this beautiful morning. Okay, today is the second day of our summer school and we have a very special topic about body composition assessment technique. And now we have already had Professor Masa, Deputy Director of the Institute of Human Nutrition Science, Kagawa University, Japan, and our beautiful lecturer as a moderator, Ms. Emi Reisa Ishaura, SVZ, MPH, PhD. She is a lecturer from Department of Nutrition, Faculty of Public Health, Airlangga University. Good morning, Professor Masa and Dr. Emir. How are you doing today?
Morning. I'm fine.
Okay,
Good.
that's great. Okay, are you ready for our second day of summer school?
Yes.
Okay, thank you so much. All right, ladies and gentlemen, without any overdue, I will give today's summer course to our moderator. To Dr. Emir, time and screen are yours.
All right. Thank you, Patiato. Okay. Good morning, Prof. Masa.
Morning.
Okay. I'm sorry, Prof. Masa. Your voice is like too small. I think make louder, please.
Okay.
All right.
Can you hear me okay?
Yes. It's clear now. All right. Okay. Good morning, everyone. I hope everyone's still excited because our second day is about the body composition assessment techniques. So if you guys have a lot of questions last Monday about how to use the body composition, how to apply the body composition if we want to do some others, maybe some research or want to apply the diet related, maybe today you can have some answer or maybe another question from Masa related to the techniques. Okay. If you guys ready, now I will give the time and screen for Professor Masa to deliver the excited topic about the body composition assessment techniques. Professor Masa, time is yours. Thank you.
Thank you. Okay, can you see the slides okay?
It's okay, but it has the two screen, the big and small. I think it's
Okay, how about this?
okay, this one is right.
Okay. Okay, good morning, everyone. And I hope you had a good rest after quite intense lecture yesterday. Today is the second day of this special series or lecture series. And today's topic is a body composition assessment technique. I wonder how many of you have had experience in body composition research in the past. But today I'd like to go through quite a range of different assessment techniques with advantages and disadvantages for each. So if you come up with questions regarding the content of the lecture, as well as any questions which you might have from your experience from your body composition research, please throw me the or questions at the end of the lecture. I am happy to answer as much as possible. So today's topic have 3 points to learn. First is to learn that there is 3 different levels of body composition assessment techniques. And I want you to make it clear and able to distinguish between body composition assessment techniques into different categories. And the second point is to acknowledge pros and cons of each body composition assessment technique. And then last point is to understand application of anthropometry in estimation of body composition. So first, we have to ask ourselves why we are assessing body composition. What this assessment is for. The first is to determine health risk of the person of focus or person of interest. The second is to starting point, to set a starting point from where to refer from. So if you are going to administer any intervention or treatment, and for example, for weight loss program, you have to first understand what is the condition of your patient at the beginning. And then, of course, when you conduct intervention or treatment, you have to set a goal. And to set this goal, body composition assessment is useful. And obviously, during this intervention or treatment, you have to monitor the patient. So if the program is progressing well. So to track progress towards goal is another reason for conducting body composition assessment. And with regards to, or in relation to sports science, the body composition assessment is useful in order to check suitability for a particular sporting event. To if there's any criteria or any information about the ideal physique or ideal amount of fat-free mass or muscularity, then body composition is useful to distinguish athletes who meet these criteria. And another point is in relation to body image. Body image is any sort of image on yourself or the others about physique or appearance. So if this is more related to psychology, but if you want to find out why people want to be thinner, why people trying to get to more proteins or supplements, you may need to understand what is their ideal physique. Then if this ideal physique is a reflection of body composition or just appearance or just body mass, then this body composition assessment is one of the techniques you may be able to apply. So this is a revision from yesterday. There are different ways to differentiate body composition, and the all techniques that I am going to introduce you today actually looking for different aspects of body composition. So you need to apply, or you have to select appropriate technique depending on what you want to find out or what you want to determine. So this is the first point that you need, or I want you to learn. The 3 levels of body composition assessment methods is level 1, level 2, and level 3, which named as direct assessments, or direct methods. Level 2 is indirect methods. And level 3 is doubly indirect method. So vast majority, or I may be able to say all, body composition assessment techniques can be put into one of these categories. And now I'd like to introduce popular techniques in this lecture today. First is level 1 technique, or direct technique. And we call it direct because we directly assess a person's body composition, which means we actually dissect a person's body. Because in order to do this, we cannot do this technique to a living person. So this direct method is more or less cadaver analysis. We are using the person's body who passed away, but who are willing to offer their body for the advancement of science. We may able to assess in two different perspectives. One is a chemical analysis, which examines the amount of fat, water, nitrogen, and minerals that construct this person's body. The other is anatomical analysis, which dissects and split into skins, adipose tissues, muscle tissues, bones, and the residuals. Well, obviously, by assessing person's body directly and took all skins off, separates bones and muscles, and separates all organs, and we can weight them directly, and we can determine the proportion of each components directly. So this is the most accurate and true values of all assessments. And because this is very, very rare occasions that we can do this kind of assessments, we can determine that if other methods of body compositions is measuring appropriately based on their assumptions. And other techniques, because we cannot measure a person's body directly, like cadaver analysis, we have to assess body composition based on assumptions. And those assumptions, we have to examine if they are true or valid. And for the comparison, for the assessments of validity and appropriateness of assumptions, cadaver analysis is, I would say, probably the only technique to examine. But on the other hand, there are a number of disadvantages or difficulties. Well, the first is, as I just mentioned, it is very difficult to conduct cadaver analysis. This is very, very rare opportunities. And also, it's very, very limited data available, especially with regards to chemical analysis. And also, we cannot include any data we cannot include people who passed away due to disease or like unusual conditions. So most cases, the data is from elderlies who actually passed away naturally. Therefore, the data obtained from cadaver analysis may not be applied to young children or young adults. And of course, to conduct cadaver analysis, there is a huge burden to both researchers and also to the family who are providing the body of their loved ones. Another technique which we may be considered as a direct method is neutron activation analysis, or NAA. This was originally invented in 1936 to determine an amount of atoms by Halsey and Levi. And this concept is basically that the human body constitutes of atoms, and some atoms actually undergo nuclear reactions when exposed to neutrons. Therefore, those atoms become radioactive and emit gamma ray when it decays. So therefore, if we can obtain, or if we can measure these gamma rays from these radioactive atoms, we may be able to estimate proportion of compositions or the elements. There have been a number of different types of NAAs. We call it in vivo neutron activation analysis. First technique is prompt gamma neutron activation analysis, or PGNAA. This technique is used to any elements that produce very short-lived gamma rays, such as nitrogen. And it has been reported that the accuracy and precision for body nitrogen ranged from 2 to 6% under condition of 15 to 30 minutes scanning time with total dose of about 0.3 millisievert. While the PGNAA is for elements that produce very short-lived gamma rays, for those elements that produces gamma rays for a long time, it is possible to utilize delayed gamma neutron activation analysis, or DGNAA. For this assessment, we usually use the whole body counter. That's a huge facility or equipment to detect gamma rays. And usually, or in general, this is like a facility-specific operating procedures, and there hasn't been much of standardized operating procedures across different research centers. This is depending on the availability of what neutron source they use, and also the gamma counting system they have. The third technique is called inelastic scattering activation analysis, or pulse activation analysis technique. This technique is a way to use non-continuous neutron beam that allow the detection of gammas produced during the burst of the neutron pulse. And it requires high energy neutrons that can only be produced by a specific generator that must be operated in a pulsed mode. Therefore, in order to apply this technique we have to have very specific, sophisticated equipment. And this technique is known to be applicable in assessment of body carbon for index to assess the body fat. But this technique apparently require a further evaluation. Using this technique, neutron activation analysis, it has been reported that quite a range of elements can be examined. Here are only the examples, starting from calcium to like sodium, chlorine, phosphorus to nitrogen, hydrogen, oxygen, and carbon, which I mentioned yesterday as the major elements that constitutes human body. But in addition, the other elements that the NAA can determine, this include cadmium or iron or aluminium. So it's a quite a useful technique if we can operate this facility, this equipment precisely, and have a skill to do that. And because these particular elements tend to accumulate in particular organs of our body, so by assessing these elements, we may be able to determine the mass or volume of specific organs, such as kidneys, brain, or bones. So it appears to be a useful technique to assess human body composition. The question is whether this technique can be considered as a direct method or not. While this technique has been considered as direct technique by certain research groups, we have to acknowledge that this NAA technique is based on the chemical model assumptions, such as more than 98% of total body calcium is in body, and total body protein is 6.25 times of the total body nitrogen, and not less than 95% of body carbon is in body fat. So because this NAA technique relied upon these assumptions, it is not really direct, frankly speaking. Therefore, we have to utilize the results with caution, and we may need to differentiate between this Kagawa analysis and NAA to be equivalent. And this NAA is in fact conducted on cadavers for only 2 cadavers to date, and there is although the results showed a quite high accuracy of 0.7 to 9%, depending on the elements of focus, I think there is a further requirement for the evaluation and validation of this technique. So these are the advantages and disadvantages for NAA. First, advantages is that it is based on chemical model. So it is only NAA that we can determine body composition in atomic level of body composition. So this is advantage. And although it uses radiation dose, is within acceptable range of 0.1 to 3 millisievert. And also it's acceptable precision and accuracy. And recently, although it is still expensive, installation cost or initial running cost for NAA has declined. So it is now cost similar to DEXA. Disadvantages, on the other hand, as I just mentioned, that it involves radiation. Therefore, it requires licensing and safety operating procedure. And also, there's no global standard procedures for NAA at the moment, so it is difficult to compare the results between different research centers. Also, I also mentioned this, but the data that compared or data based on cadaver result is still limited. And it is essential to have a skilled technician to operate this technique. So there's experienced staff for calibrations and operation must be prepared. And probably this is the most important, but the facility, the equipment itself is very limited and no commercial instrument is available at the moment. So these two I put into the direct method. And now I'd like to move on to level 2 or indirect methods. Indirect methods is basically based on the two-compartment model, which differentiates human body into fat mass and fat-free mass. And probably this category is the most common category, and quite a huge number of techniques fall into this group. The common techniques include densitometry, dual energy X-ray absorptiometry, or hydrometry, and total body potassium, and so forth. Each technique measures human body composition based on certain assumptions, and this is the most important limitations of level 2 techniques. But by combining different techniques at once, we may be able to increase accuracy and precision of body composition assessment. For instance, it is possible to, if there is a facility, it is possible to administer or conduct densitometry, hydrometry, and dual energy X-ray absorptiometry or DEXA to the same person. In this way, we can eliminate assumptions one by one, and we can differentiate human body not only into fat mass and fat-free mass, but fat mass and body fluid and bone mineral content and the rest, so which is 4 compartment. So if you are lucky enough to have access to these techniques at once, then you may increase accuracy and precision. So here I like to explain each technique one at a time. First of all, densitometry. Densitometry is also known as underwater weighing or water displacement method. And these techniques are mainly aimed to assess body density. So body density, to assess body density, this densimetry can be considered as a gold standard. This densimetry is based on the principle of Archimedes, which is also known as principle of buoyancy. That means this buoyancy principle is when an object was immersed in fluid, the net buoyancy force is equal to the weight of fluid displaced by the object. And we can say that higher the density, lesser volume of water displaced. So there is a specific relationship between density and mass. And here is the actual equation of the principle. So density is mass per unit volume. That means mass divided by volume. And this association or this relationship can be further break down into mass in the air divided by difference between mass measured on the ground and in the water, with assumption that density of water and residual volume being specific. And consequently, mass measured in the water is equal to the mass of water displaced. So densimetry is gold standard or to assess body density. However, there are assumptions associated with this technique. There are a number of, but these are the major ones. First, the separate densities of the body components are additive. The second is that the densities of the constituents of the body are relatively constant from person to person. The third, the proportion of the constituents other than fat are relatively constant from person to person. And the last, the person being measured differs from a standard reference body only in the amount of body fat or adipose tissue. So when we conduct underwater weighing technique, we are assuming that these assumptions are true and consistent or across person to person. So from the chemical analysis of cadavers, the Going reported this table, and when you checked the actual densities of fat-free mass and fat mass, we can find out that fat mass is 0.9007 and fat-free mass has a density of 1.1. This means that a human body has the body density is between 0.9007 to 1.1. If the person has 100% body fat, or if the person has or composed of fat 100%, then this person has a density of 0.907. If the person has absolutely no fat at all, then a person has body density of 1.1. That is the assumption. And because densitymetry or underwater weighing or water displacement method is only assessing density, and in order to estimate actual body fat level in the way of percentage body fat, we have to enter these values obtained from densitymetry into prediction equation or conversion equation proposed by either Siri or Brozak. These two equations are common equations to convert body density into percentage body fat. And this is actually up to individual researchers for which equation to use. Either equations provide the clinically non-significant values. The difference is, I would say, statistically significant, but clinically not significant. So it is up to individuals whose equation to use to convert body density to percentage body fat. However, you have to go back to assumptions and consider whether these assumptions are true or not. If it is not true, then we have to consider the accuracy of utilizing this technique for body composition assessment, or at least we have to take care. We have to interpret the results with caution. Well, first of all, we have to acknowledge that body composition alters throughout one's lifetime. That means a person's body composition, the amount of fat mass or amount of fat-free mass changes as they grow, or depending on his or her lifestyle or diet or exercise, energy balance. Then there are fat-free mass and fat mass densities also change. Therefore, the assumption that there are these fat mass and fat-free mass densities being constant is not true. And Lohmann has actually proposed that because body density of individuals vary, especially the equation proposed by Siri and Brozak, their equation is based on cadavers obtained from adults or cadavers of adults. Their conversion equations may not be useful to estimate percentage body fat of children. Therefore, Lohmann proposed children-specific equation to convert body density into percentage body fat. Also, within adults, for instance, the density of fat-free mass may be different depending on the person's exercise or physical activity level. This is a study conducted by Adams in 1980s. He examined 29 professional football players and examined their body density using underwater weighing and convert the results into percentage body fat, and also took skin folds to obtain some of 10 skin folds. From the results, since all football players had skin folds, that means everyone had some certain amount of fat mass. However, when the results from body density have been converted into percentage body fat using series equation, of 29 athletes, 9 athletes showed either 0% body fat to minus percentage body fat values, as much as minus 12%. This is unusual. This is something is not right, because as long as there is a skin folds, everyone should actually show positive percentage body fat. But these 9 athletes did not. So if we go back to the associations or relationship between percentage body fat and body density, we know that there is almost linear inverse relationship between the two. But due to the fact that this equation is based on constant density of body density from either 0.9007 to 1.1, if the person had body density greater than 1.1, we will show negative percentage body fat value. It's quite easy to understand that these 9 athletes showed negative values because they had much high body density. But until this time, Adams find out this mathematical error has not been focused too much. Therefore, we have to understand that as long as there is some equation need to be applied, and this equation is based upon assumptions that may not be true for some person or some people, we have to acknowledge there is a possible error in this estimation of percentage body fat. So this is the summary for pros and cons. Or underwater weighing or water displacement method is relatively cheap. Cost has been declining, and most laboratories have equipment to measure residual volume, so it's usually easy to set up. And also densitometry have high accuracy in measurement of body density itself, and it can estimate percentage body fat from measured body density, although there is some assumptions that we have to acknowledge. Disadvantages include there is some requirement of space to set up the facility, because this technique requires some space that participants to immerse under the water. So there is a need to set up a pool or water tank kind of a facility. And it is difficult to apply to particular populations such as elderly, infants who cannot swim or have very poor ability to swim, and also who are hydrophobic, scared of water. And because in the majority of cases, we request participants to immerse under the water several times and exhale the air that is in the lungs while he or she is immersed under the water. So it is quite high burden to participants. And lastly, the assumption may lead to error to estimate percentage body fat. And since underwater weighing or water displacement method have these disadvantages, especially incapability to assess elderly or infants who have a poor ability to swim, nowadays there is a new equipment or relatively new equipment that uses air instead of water to displace from the area or the assessment equipment. This technique is known as air displacement plethysmography, or ADP. And this ADP has been widely accepted nowadays because it's not required for participants to submerge under the water, so it's a lesser burden, and it has good agreement still with underwater weighing, and it is not invasive, relatively fast. One measurement takes about 30 seconds or so. So by within 5-10 minutes, we may be able to complete all 3 sets of assessments, and also relatively safe technique. And the downside of ADP is that although we already know that the assumptions utilized for water displacement method or underwater weighing is not true, ADP also applies the same assumptions with underwater weighing. And in addition to the considering constant densities of fat mass and fat-free mass for ADP, it also measures surface area and thoracic gas volume into account to determine body density. Because ADP is so non-invasive and fast and safe, it has been utilized for body composition assessments for children or infants. And this specific equipment for infants is known as PPOD, and it apparently able to complete all measurements by or within 2 minutes. And nowadays, all topics of epigenetics and childhood obesity and epigenetics have become well understood and well recognized. The body composition assessments from early life stage, such as infants, have been focused, and this is one of the field which may be expanded to a range of research topics of growth, overweight and obesity, the epigenetics, as I said, and cross-racial differences. The next topic or next equipment is DEXA. DEXA was originally invented to determine bone mineral density of body parts. The initial equipment was to measure and reduce bone density, but now the equipment has changed its size and design, and nowadays this DEXA shown in the photo, like bed-like design has become popular, and participants just lay down on the bed, and DEXA scanner, which you can see from the photo, scans participants from the head to the toe. That enables to determine not only bone mineral density, but also body composition, such as lean body mass, fat mass, bone mineral content, and so forth. And this DEXA utilizes two different types of X-rays, and therefore there is some associate, or there are some involvement of radiation exposure. But by using two different types of X-ray particles, we can determine the differences of tissues by assessing differences in penetration of these X-ray particles. And the results can be obtained as the whole body, as well as regional body, such as the head, the trunk, arms and legs, and also hips, and so forth. And also it is possible to set specific region of interest, such as abdominal region or gynoid region, to obtain more specific and appropriate values for individuals' research. The assumptions associated with DEXA includes the lean body mass contains water, and it is about 73.2% of lean body mass. And there is an assumption that a brain has 17% fat. And due to the fact that we have quite complicated mixture or a complicated what we call it, how we say it, location of each organs in the trunk region, it is difficult to measure body composition of the trunk region accurately. And of course, due to these assumptions, we cannot apply or we cannot expect accuracy from particular populations, such as the differences in hydration affects the accuracy of individuals, and Lohmann suggested that the changes in hydration status for 5% results in changes in percentage body fat of 1 to 2.5%. These are the pros and cons for DEXA. The advantage for DEXA is that it requires quite short time to assess. The old time, DEXA took about 30 minutes to scan, but now it takes about 5-6 minutes for individuals, and if requires, takes about 10-12 minutes to scan, depending on person's level of obesity and other factors. And it is known that the DEXA has highly reliable, the high inter-technician differences between when we actually measured body composition by 2 different operators. And it's relatively easy to access. Quite many hospitals and clinics tend to have DEXA in their facility, and it is cost efficient compared to the other techniques, and also high correlations with them. And now nowadays, current software program, it enables estimation of visceral fat. On the other hand, disadvantages including radiation exposure. So any females or infants who need to avoid radiation exposure, we cannot conduct DEXA on those people. And it's relatively expensive. So it's expensive for the fast setting up the facility. And there is some debate on accuracy, that some study using small amount of pigs suggested that the DEXA is quite accurate. However, the other study that utilize more number of pigs with more diverse body size suggested that there are some diversity and variability in the measured results. And there is some need for further investigation on accuracy. And it is difficult to compare results between machines which was manufactured by different company particular, but within the same company, due to the differences in beam types or version of scanning softwares, they may require some caution for interpret the results. And also there's a effect of scanning size. If the person has more than 2 meter height and heavier than 130 kilograms or so, we not really allow participants to lay down on the bed for safety reason. And since I have been mentioning some radiation exposures in body composition assessment, here I listed some of the examples of radiation exposure levels and body composition assessment techniques. The last row shows the DEXA result. To assess bone mineral density or bone mineral content, it takes only less than 0.01 millisievert. So we can say that it is very, very small amount compared to ordinary chest X-ray. But for neutron activation analysis, which we can use for depending on the focus of the elements of the focus, it's if we use delayed gamma neutron activation analysis, sometimes it's actually exceed more than 2 millisievert. If this technique has been chosen to use body composition assessments, then we have to very careful in screening process and make sure not pregnant women or children to receive excessive amount of radiation exposure. Now, this is a next level 2 technique. We call it as hydrometry. The other way of saying is total body water. As you can assume from this name, this technique are going to estimate the amount of body fluid as water is most common component in the human body. How we determine human body water is from using isotope of and dilute the isotope and administer it to participant, and then later compare the samples collected before and after administration of these isotopes. There are a number of isotopes we can utilize, such as deuterium, tritium, and oxygen, and bromine. Because tritium is associated with radiation hazard, and oxygen is quite expensive. Oxygen 18 is quite expensive. It is very popular to use deuterium oxide as a source for or the isotope for hydrometry. So here we utilize what we call equilibrium technique. So total body water can be sampled as saliva, urine, or plasma. But what we need to do is request participant to collect any of these samples before and after administration of isotopes. And inaccurate intake will actually cause a huge error. So it is important to collect sample and weigh accurately and administer the accurate amount of isotope to the participants. So once the participants collected the baseline sample, we request participants to consume deuterium oxide specific to their body mass. Then the consumed deuterium oxide will be mixed with body water within a few hours, like 2 to 3 hours if collecting saliva sample, and 3 to 4 hours if collecting urine sample. But we have to understand that the timing to collect post administration sample varies by which sample you are using, such as saliva or urine or blood, and also the age of the participant. Adults has been suggested to be takes longer time to reach equilibrium compared to children. And hydrometry can be utilized to assess body composition of not only adults, but also for children, especially for infants. And this is based on the assumptions that because infants actually consume breast milk, and the breast milk is liquid, we can administer adequate amount of isotopes to mother. Then the deuterium will be distributed evenly to breast milk as well. So if the infants actually suck breast milk from their mothers, then there should be some enriched deuterium oxide in the infant's body fluid. And by collecting urine sample from children or from infant, we are assuming that there is a possibility of assessing body composition of infants. The deuterium oxide or total body water has also a number of assumptions to consider. First, the deuterium oxide is assumed to be distributed only in body water. And deuterium oxide is equally distributed in all body water compartments such as saliva, urine, plasma, sweat, etc. And the rate of equilibration of deuterium oxide is rapid. And neither deuterium oxide nor body water is lost during the equilibrium time or equilibration time. The question is any of these assumptions true or not? What do you think? These are the fact. The first assumption is false. Second assumption is also not true because lesser in water vapor. And for the third assumption, people with slow water turnover takes more time to equilibrate. And the fourth assumption, fluid intakes and physical activity can increase fluid loss during the equilibration. So that, in other way of saying, if participants eat or drink after administration of the deuterium. Another difficult part of total body water or deuterium dioxide or deuterium oxide is that we require analyzing facility. There are several different equipment that you may able to utilize. The one is isotope ratio mass spectrometer or IRMS. The second is a little bit more cheap and maybe applicable for with a certain validity, is that the Fourier transform infrared spectrometer or FTIS. And these machines analyzes the samples you collected from participants. So both pre-administration and post-administration samples. And but if you are going to analyze, say, saliva, then FTIS can be utilized, can be used. But if you intended to collect urine or blood sample, then IRMS is required. And once total body water was analyzed based on some assumptions, then fat-free mass can be estimated based on the assumption that hydration status of fat-free mass is constant and known, which is 73.2%. So this is the revision from yesterday, that mammals has on average have 73.2% of lean mass consists of water. So this value is actually can from this study. But in fact, this hydration status also vary depending on individuals. There has been reported that the hydration status vary from 70.7% to 76.3%. So not everyone has 73.2%. And for in healthy subjects or healthy people, it is not less common that water content vary by less than 2% from day to day. And there is a difference in hydration status between infants and adults. And there is no that it is may not be valid in situations where patients have expanded extracellular water. So such as during pregnancy or in children with edema. So these are the some of the examples which also showed yesterday. Infants had higher hydration compared to older age groups. So here are the advantages and disadvantages of total body water. Advantages include deuterium oxide is relatively cheap and less burden to participants. That means once participants provide us pre-sample and administered or consumed an appropriate amount of deuterium oxide, then the person can walk around or do not have to stay at the laboratory until he or she took a post sample. So we can provide them more freedom compared to the other techniques. And it has been reported that total body water technique is highly reliable and also accurate if properly conducted. Disadvantages include we require spectrometer for analysis, and also to operate spectrometer, we have to have a skilled technician and training for this. And hydration status can vary depending on individuals. So until now, we have gone through direct methods and indirect methods. You can see clear differences between each technique, and I hope you have not really get confused to date or at the moment. Now I'd like to move on to level 3 technique, which is also known as doubly indirect method. The techniques that fall into this category is, first of all, we have to understand that the techniques in this category are originally not invented for a purpose of body composition assessments. Techniques included in this category include bioelectrical impedance analysis or BIA, anthropometry, ultrasound, and near-infrared spectroscopy. There are more techniques that is not shown here, but all these techniques are originally not to assess body composition assessment or not to assess body composition. And because of this, we have to have some prediction equations to estimate body composition of study population when we utilize doubly indirect techniques. That's actually convert the values or variables we obtained from these techniques to percentage body fat or fat mass or body density. So how we develop prediction equations for doubly indirect techniques. The simplest way to understand is that we actually conduct measurements of both level 2 and level 2 methods on one person. So if the participants first measure body density using underwater weighing or underwent scanning, whole body scanning using DEXA, and then later measure the person using skin folds or bioelectrical impedance analysis or ultrasound. Then later we can utilize statistical technique such as regression equations or correlations. And we can add variables obtained from doubly indirect techniques as independent variable, and using percentage body fat or fat mass or body density obtained from level 2 techniques as dependent variable. Then include age, gender, ethnicity, exercise level or physical activity level into the equation as well. Then we can come up with prediction equations which can estimate percentage body fat or body composition with high accuracy or high reliability. But these prediction equations derived from or derived for doubly indirect methods are population specific. That means if you want to predict body composition of Indonesian adults, there is not really a point utilizing prediction equation which was derived from Caucasian population living in England, because their body size, race, genetic factors, lifestyles, these are all different. So make sure you actually choose appropriate prediction equations when you are trying to use doubly indirect techniques for your body composition assessment. So this is what I just said. Tips to select appropriate prediction equations. If you choose certain prediction equation, you have to have already checked that race, age group, gender, physical activity level, or health status to be comparable to what you are researching on or who you are researching on. And if you're using prediction equations derived from anthropometry, then obviously you have to be certain that the measurement sites or equipment measured skin folds or techniques or protocols are all consistent with the techniques utilized in prediction, or utilized to produce prediction equations. Because there are so many prediction equations, we can enter the measured values into different equations if you want. But in this case, this is just an example, but I have entered the same anthropometric skin fold values into different prediction equations to estimate body composition. Then the results was very clear that some prediction equation shows percentage body fat of 7.6%. However, other prediction equation shows the results of almost double of the first equation. So we have to be cautious about prediction equation, predicted values obtained from equations when you utilize the level 3 techniques. So with emphasizing the importance of acknowledging possible error or potential errors in prediction equations, I'd like to talk about the concepts and errors or advantages and disadvantages of bioelectrical impedance analysis. This BIA technique is one of the most popular techniques of all body composition assessment techniques, and it has been so many diverse equipments available on the market today. They ranged from its shape, design, the number of electrodes, the number of electrical frequency, or the amount of frequency. So it's up to individuals which device to purchase and utilize for your research or monitor health status or assessing body composition of your clients. So the concept or background of BIA technique is that electric current always conducts through a circuit with less resistance. So it's usually tissues and fluids like cerebrospinal fluid, blood, skeletal muscle tissues have a very large amount of fluid and with electrolytes. Therefore, these tissues have very high conductivity, whereas tissues and organs like fat, bones, or the lungs, where a small amount of fluid or filled with air, these places have high resistance. So, by assessing the differences in speed of electric current going through our body, that means assessing the conductivity and resistance of electric current, together with understanding the volume of body fluid, length, and composition, and also calculating impedance, we can utilize these variables to assess total body water and the total amount of body fat. And here I said impedance. Or impedance can be calculated from resistance and reactance as shown in the equation here. But once impedance and reactance can be assumed that the volume of water is length multiplied by area, this equation can be converted to resistance is equal to length squared, that volume of water is equal to length squared divided by resistance. And this length, meaning body height for human body composition or human body assessment, so it can be modified into stature square divided by resistance. And because resistance can be determined from BIA, so we can able to estimate total body water. And with regards to BIA, we have to also understand the different types of BIA that uses single frequency and multiple frequencies. Single frequency BIA generally use electric current of 50 kHz that penetrates cell membrane. So this type of device just goes through intracellular fluid and extracellular fluid and determines total body water. On the other hand, a multi-frequency device, it's depending on the device, but it actually use the frequencies that are less than 50 kHz and those above 50 kHz. And usually frequencies above 50 kHz provides both extracellular and intracellular fluids, and frequencies below 50 kHz or usually 20 kHz and below, this cannot go through intracellular fluid, or it cannot penetrate cell membrane. So lower frequencies can only able to determine extracellular fluid. By having such difference, we can determine intracellular fluid more accurately. So BIA is has a number of advantages because it is readily available, and our cost range is also wide. So we can obtain cheap BIA device that is on the shelf to a very, very expensive device depending on your budget. And so it's as long as you understand which device to use, it can be very cost effective, and it's very simple to conduct, and many devices are portable, and it can be conducted very quickly and non-invasive. Recent devices have quite comprehensive functions that also estimates basal metabolic rates or visceral fat level or bone or muscle quality or so forth. Sometimes it's some devices actually estimates waist circumference or upper arm circumference from the measurements. There is a doubt about accuracy of these values, but some devices do have such functions. On the other hand, disadvantages including the BIA is assumed human body to be a single cylinder, but in the reality is not. Reality is that the human body is a combination of 5 cylinders of different lengths and diameters. So it's more complicated or complex. Therefore, it is possible that the BIA do contain some errors in measurements of impedance. And it requires prediction equations, as I mentioned. Therefore, by selecting incorrect prediction equations, the estimated body composition values are very erroneous. And also, lastly and most importantly, BIA is strongly affected by the hydration status of participants. So if the participants were dehydrated, it will affect estimation of percentage body fat. Also, if the person consumed a cup or glass of water, or had a meal, went to training, or had a bath, all these activities affect hydration status of participants. So because body water is readily changed throughout the day, it is important that the measurements to be conducted at the ordinary or normal hydration status, and when the person is going to be monitored using BIA device, the measurement time should be being consistent. And anthropometry. Well, anthropometry is measurements of size, shape, and proportion. And it's including stature or body mass measurements, skin fold thickness, breast circumferences, and length. These variables can be utilized to estimate body composition, but in most cases, skin fold thickness is the major variable that has been utilized for estimation of body fat. Therefore, I'd like to list some assumptions related to skin fold measurements. So all these 5 assumptions are constant compressibility regardless of any person or any locations, skin thickness being constant regardless of people or locations, a constant adipose tissue patterning, or constant fat fraction in adipose tissue, or internal to external fat relationship being fixed. Unfortunately, these assumptions are all false. So we have to first acknowledge that we are conducting skin fold thickness measurements with some error or the chance of entering error in the measurements. Having said that, there are some prediction equations available. So if you are interested, you may use these equations to estimate percentage body fat of participants. And here are some examples which I have been involved as a co-researcher to derive prediction equations for Indonesian adults. So if you are interested in, please have a Google search or PubMed search and have a look at it. And the other way of assessing body composition using anthropometry is an approach known as fractionation. This is a concept that body mass is a sum of different tissues, which is true. And the first person who proposed this concept was a Czech anthropologist, Jindřich Mačerska, and he focused on 3 components, such as skeleton, muscles, and fat. But this was expressed by Brozek and Prokopek as body mass is a sum of skeleton, skin, and subcutaneous adipose tissue, skeletal muscle, and remainder. This approach has been considered by many other researchers, and Bank estimated body weight using 11 circumferences. Drinkwater and Ross also proposed a new fractionational model using the unisex phantom, which I introduced yesterday. In this case, they summarized body mass is a sum of fat, bones, muscles, and residuals. And later, Carr proposed 5-way fractionation method, which separated skin and fat together with bones, muscles, and residuals. This is a very interesting approach, I think, and there is a way, there is some space for further evaluation and investigation, but there has been suggested some systematic errors and some technical errors in this fractionation approach, especially used by Drinkwater and Ross. And from my personal opinion is that this is very interesting, and unfortunately there is no such study that examined validity of this fractionation method to Asian population. So I am very much of interest to conduct such study in future. So because anthropometry has some erroneous potential in estimation of body composition, which is consistent to BIA, but the big difference from BIA and other doubly indirect methods is that anthropometry is very useful and very able to utilize direct results of skin fold thickness as an indication of adiposity. So this is one of the example that by simply assessing a subcutaneous fat or skin fold, then I can able to compare different populations or able to monitor the single person for longitudinally. So if you have a good skill on anthropometry and skin fold, it is more recommended not to rely on prediction equations, but to utilize the actual value itself. And this is some study reported the high correlation between the results obtained from DEXA and anthropometry. As you can see, although this is from children, but the sample size is quite huge, if you compared different variables from anthropometry and the related anthropometric indices, you can see that the sum of skin folds have highest correlation with DEXA results. So my recommendation for anthropometry is to use actual values and at least some of skin folds. However, in order to utilize anthropometry, you have to have good technical skills and statistical knowledge. From technical perspectives, you should have good understanding on technical error of measurements, and you have a good understanding on equipment. With regards to statistics knowledge, you have to have a good understanding on protocols and errors associated with equations. And to have a good understanding on these, it is highly or strongly recommended you to have training sessions beforehand, and you have to have good confidence about it. So the pros and cons for anthropometry. The advantages is readily available, cost-effective, simple, non-invasive. These are very similar to BIA. But the specific advantage for anthropometry is it can directly able to assess subcutaneous fat, and it can show fat distribution pattern. So disadvantages is it's largely influenced by scale of a measurer, and we require prediction equations, which may allow some errors to come into the place. So just lastly, I'd like to briefly introduce this ISAC protocol. This is the protocol proposed by the International Society for the Advancement of Kin Anthropometry. And this organization proposed an international standards of anthropometry, which has been widely accepted by worldwide, and especially in health and sports science disciplines. And if you are interested to obtain this international accreditation, there is a possibility to attend accreditation course in future. And since I have a good relationship with universities Airlangga, I hope I have a chance to visit Indonesia in future. And if there's anyone who are interested to obtain this accreditation, I'm happy to conduct accreditation course in future in Indonesia as well. So to conclude today's presentation, so body composition assessments are valuable in understanding participants' health status. And methods can be classified into 3 categories. So please remember this direct, indirect, and doubly indirect methods. And most common body composition assessments is based on 2-compartment model. And you have to acknowledge pros and cons for each body composition technique, assessment technique. And my strong emphasis is that none of the available techniques is perfect. So you have to understand advantages and disadvantages very well in order to select which technique to utilize for your research or your assessment. And for anthropometry specifically, it is recommended to utilize measured values instead of rely too much upon prediction equations. So this concludes today's session, and I hope you enjoyed it. And if there are any questions, please let me know. Thank you.
Right. Thank you, Prof. Masa. It's really interesting topic. For me, myself, I learned a lot from your lecture these 2 days, and I hope the next day also is have some excitement, the same as today. All right, we come up with the question and answer section. Okay, we have the first question is from Nikmah Utami Dewi from IPB. All right, thank you for the material and very comprehensive explanation, Professor. Question, because BIA is highly dependent on the hydration status of the body. So is it really necessary to specify that the subject should not exercise and drink a few hours before the measurement? If yes, how long should it be?
Yes, thanks for the question. Tami, was it? Yes, it is important to instruct participants to avoid any exercise or eating before the assessments, and how long prior to the assessment is depending on the background of the characteristics of the participants. The lengths may be different between children and adults. So you have to be to consider about characteristics of the participants. But usually I would say like 3 to 4 hours before before 3 to 4 hours of assessments, I would recommend participants not to do exercise or eat food. So, and also it is suggested to void before the assessments. So make sure to everyone to go to toilet beforehand and then conduct the assessments.
All right. Okay. For BIA, how long usually it takes time, like for full measurement?
For what?
The BIA. I mean, like from the start, including the preparation until the finish. So, for example, for adult, that normal adult, not athlete or something, you recommend that 3 to 4 hours prior the measurement. So is it including the preparation? Maybe they have to the class and blah 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 before they go into the BIA.
No, because BIA takes only a few minutes. So BIA itself is just stands on the weighing scale or lay down on the bed and take a measurement. It only takes a couple of minutes. So to have a better results and consistent results, just make sure participants to not get sweat or consume excessive amount of fluid about 3 to 4 hours before the measurements.
Oh, okay. All right. Okay. Thank you. And then the second, all right, from Dr. Jean, yesterday, thank you, Prof. Masa. She has the answer from the lesson why the difference of BIA cannot show the ICWN, ECWN, other type equipment show only total body water that based on the single or multiple frequency. So it's she got the answer from the yesterday question.
Good.
Remember. All right.
That's good. Thank you.
All right. Maybe anyone has another question. Okay. And I'm also wondering, for example, I want to prepare my athletes to reduce or maintain the body weight into the certain class of competition. how many types of anthropometry measurement that I have to prepare, at least if I don't have like the advanced equipment. For example, I have to check how many anthropometric.
You mean how many occasions we need to conduct measurements, or how many measurement sites to measure at one time?
Yeah, I mean, for the index, for one time, I have to check, for example, the body fat. We can use like so many index, right? So use what you suggest, like how many index that I can use, like I mean, like certainly get the
result. Yes, just to simply to obtain subcutaneous fat from skin folds, if you can take 8, that would be great. But if you have less time, if you don't have much time, then minimum of 6.
6. Oh.
However, what I need to emphasize is you need to take skin folds from both upper and lower bodies. So yeah, because there are some equations that only use upper body.
Yes.
But if the person has more fat on the lower body, then that's this actually misleading. So what I usually do is ideally to take 8 skin folds, but if I don't have enough time, then make sure I take 1 from the arm, 1 from the trunk, 1 from the thigh, and also 1 from the back, so subcutaneous or subscapular. So that makes sure I can get the image of where fat is distributed.
All right. All right. Thank you. We have another question is from Evie, University of Indonesia. Actually, I'm interested on Isaac because previously I referred to the CDC standard on anthropometry. So perhaps could you please give explanation about Isaac and what is the difference between Isaac and the CDC standard, or actually both it's the same? Okay.
Yeah, thanks for a question, Evie. The biggest difference between CDC and Isaac is that Isaac is more hands-on accreditation scheme and emphasize on the technical error of measurements. So make sure that the people who undergo Isaac accreditation course actually know how to assess on accuracy and precision of your measurement. So while CDC and other protocols that exists around the world, you have a difficulty of understanding if your measurement is correct, your measurement technique is correct, or if there's something is wrong. But for Isaac training is actually provides you good knowledge on how to conduct measurements, but also how accurate or how precise your measurement is. So this is a very important aspect, especially like this anthropometry protocol that has the potential to compare with the data reported somewhere overseas, and able to do perhaps do a collaborative research or make a comparison with reference. If you have a good understanding on how much error is associating with these values, then you can have a better interpretation of the results and the data, and also it makes much easier to collaborate with people living in different parts of the world. So that's the biggest difference. And also the variables for measurement sites. The ISAC protocol is more comprehensive than CDC protocol. The maximum would be more than 40 sites for anthropometry. The minimum is like a 20 something. So CDC protocol is, I think, much less than that. Yes.
Okay, all right. So for example, is there any requirement for if somebody, for example, myself, I want to, for example, apply for the join the ISAC or something? Is it have some requirement related to the education or something else?
Yes. For the ISAC has 4 levels for accreditation, and for the first level, there is not much of a prerequisite, but because we actually deliver theory on like anatomy, because it is important for understanding landmark for measurement. So I think it is better to have good understanding on anatomy and physiology, or a little bit of health science background to join accreditation course.
Okay. Is there? I mean, in the ISAC, is there have? I mean, like, do you have some kind of practical course that you have to like attend or something like that, or it's just like all the theory?
No, it's this courses consists of both theory and prac sessions, and the level 1 course requires a minimum of 3 days, and we have certain specific hour of theory, which is 10 hours of theory, and also how many was that? Maybe close to 20 hours of prac sessions we require. And then we also have a prac exam in order to pass the course. But after you completed the course, you further require to complete post-course assessment, which is a measurement of 20 participants, and report your own measurement error. If the measurement error is within the appropriate range or within the proposed technical error, then you are eligible to accredited. So it's a very well polished accreditation scheme. And also this course is, this accreditation is valid for 4 years. And then if you want to renew, you need to sit prac exam again, and to make sure you maintain the technique and skill.
Okay, understand. Okay, it's very interesting actually. Okay, maybe Effie, you have some others idea, you can mention it in the chat room, or others that has question related to our topic today. about the body composition assessment, or everyone already understand, which is, it's good. Okay. All right, the next is from Dr. Dean again, and she interested in anthropometry since she was at the Queensland University. It's like the densitometry and now BIA. And then why we should back using the skin fold caliper, which is not easy to measure in 11 circle body. Do you have any advice in that? Like skin fold, we have the quite advanced like densitometry and BIA, and then at some point we come back to using the skin fold caliper again, the giraffe ruler again.
Yes, yes. Well, because each technique, each body composition assessment technique have a different focus on assessment. So as I introduced you today, the densitometry's main focus is body density. Hydrometry's main focus is body fluid. So each technique has different rationale. So it is important to understand why such technique evolved or invented. And for skin fold, however, it is not really for estimation of the actual composition of human being. Anthropometry is to assess surface shape and size and proportion. And I think it is past researchers' credit that they showed some associations between body composition and anthropometry, but I think there are so many people who misunderstand that the anthropometry can be used for body composition, and without understanding the errors and the limitations which I mentioned today. So it is important for us health researchers or people who are involved in body composition assessments is that we understand pros and cons of each technique and how we conduct each technique operations, and we have a good knowledge of which one to choose from. As long as there are resources, we can choose any technique. And but if we don't have enough knowledge, then we actually choose improper technique. So I think why we have to understand body composition technique is we have a good selection. We can choose most appropriate methods to assess your study group for considering your time or your budget or safety, whatever. So yeah, and then the answer for anthropometry is it is portable and it is cheap, non-invasive, so very, very useful. But just to be careful not to rely too much on values you estimated from prediction equation. So my recommendation is to use measured values, skin folds or circumference. These are, I think, quite more than enough to assess people's health status and screening purpose. If you come to some concern, then you have to arrange more advanced technique or assessments. But or to assess participants on the field using direct measurement from anthropometry is, I think, very sufficient.
Okay, all right. Thank you for your suggestion. With this pandemic, it's really hard for some researcher to do, research, especially for anthropometric measurement. It's really hard to, you want to measure directly, it's easier. But when it's come up with the pandemic, you have some protocol that it will be hard to measure, for example, the body height, body weight, and or also maybe using the BIA or using the other. Do you have any suggestion what exactly in this pandemic, for young researcher or also the people who doing research in including the anthropometric measurement, which one that we can use in this pandemic? Do you think?
This pandemic is, yes, because all these body composition assessments do involve physical contacts and direct contacts, especially anthropometry. So all of them do have do require or careful handling, hygiene control. But if you have a budget and sufficient facility analyzing machines, then total body water may be one of the technique that you may choose. But if you don't have much of facility available, resource available, then anthropometry is still capable, but just to make sure, you have to be careful that wear face shields and masks and not stand in front of participants and positioning where yourself to stand during the measurements. That kind of little tips is required. But if anyone who are interested for points that you need to be careful during this pandemic for anthropometry, I can provide you some information sheet which Isaac has proposed. So yeah, maybe anyone, Ulan or Emilia can gather if any of the attendees wants to obtain this document, then I can send you the document.
All right, that will be good. Okay, thank you, Professor. All right, for today's course, if there are no other question, okay, I think, yeah, okay, I think we don't have any other questions. So I hope everyone can enjoy the topic today and learn a lot, because myself, I learned a lot. So I hope everyone also learned something from the today's topic. Okay, and tomorrow our topic will be the application of anthropometry in health and sports science. Okay, that will be our last course. So everyone maybe have some question, prepare yourself, and you can ask tomorrow. Okay. All right. Thank you, Professor Masa, for
the
lecture, and I give it back to the MC, Miss. I don't know who is MC. Okay, Miss Wulan. All right.
Okay. All right, thank you so much, Professor Masa and Dr. Ermir, for the insightful material about anthropometry measurements and such an interesting discussion today. Before we close today's course, again, let's have a photo session together. Okay, for all participants, please kindly to open your video camera and prepare your beautiful smile. Okay, and the host will help us to take the screen. Okay, I'm waiting for the participant to open your camera. Okay, thank you. Okay, we're gonna have 3 times of documentations. Okay, ready? Okay, let's start for the first documentation. 1, 2, 3. Okay, the second one. 1, 2, 3. Smile. Okay, and the last one. 1, 2, 3. All right, thank you so much, everyone. Okay, for the information, we provide e-certificate for all participants here. So don't forget to fill in the attendance form, which is sent by the host into the chat box Zoom. And in addition, we're gonna have a post test tomorrow, right after the last course. And please learn and remember the material we have already discussed. And if you want to get the materials we have already provided in the link, which can be accessed from the first email we sent previously to each participant. So you can check again the email from the committee. Okay, ladies and gentlemen, we have come to the end of today's summer course. Don't forget, tomorrow we'll have a special topic about application of anthropometry in health and sports sciences, which is still very correlated with our today's course. And of course, we still have Professor Masa with us. Okay, once again, thank you so much, Professor Masa, Dr. Emir, and all participants for coming. And again, don't forget to fill in the attendance form to get the e-certificate. All right, that's all for today's summer course. Wassalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Stay safe, stay healthy, and see you tomorrow. Bye.
Thank you.
Thank you, Prof. Marsa.
Thank you, Professor.